Okay, here we go, recording. Vertical angles. We need to know what vertical angles are. Vertical angles, up and down, vertical meaning up and down, kind of, to a certain degree, unless you rotate the picture and then they're no longer up and down. But that's kind of, essentially, that's where they get the name, the fact that they're vertical from each other. Like in this picture right here, 2 and 4 are vertical from each other, right? They are also classified as vertical angles. Most specifically, with the definition of vertical angles are angles that are opposite each other, and form two lines. Angles that are opposite each other and form two lines. The only way for that to be the case in the picture that's drawn are for 2 and 4. Those are opposite each other, opposite meaning not adjacent, and form two straight lines. Angle 2 and angle 4. If that's angle 2, and this is angle 4, they're opposite each other and they form two straight lines. Well, two lines that would have, the vertices would have to be shared. Okay, that's the way they get it. They visually look like they're vertical from each other in one case, but in another case they could also be horizontal. Like 1 and 3 in that picture are also vertical angles. Okay, it's just a classification. The name comes from the fact that they look like they're up and down from each other in some cases, but not quite in all cases. Anyways, as an example, there's vertical angles in this picture that I just drew, even though they're not vertical nor horizontal. Those two red angles I just drew in, those are vertical angles to each other. Okay? The reason why the heading on this piece of paper says congruent angles, it says congruent angles because vertical angles are actually congruent to each other. Does that make sense to you just by looking at the pictures? I think visually it makes total sense. The fact that 2 and 4 in this picture right here, 2 and 4 look like they're the same size, just looking at it. Okay, and they actually are 100%. Okay, and the reason why they are, kind of a little mathematical proof for you. If you look at this picture, we've already talked about how angle 1 and angle 2, in this case, form a linear pair. We've already talked about that linear pairs is supplementary. So we have this statement that we can write measure of angle 1 plus measure of angle 2 equals 1/8. Does that make sense? Can you agree that we can write that based on this picture? Okay, based on okay, the same thing is true with 2 and 4. Okay, or 1 and 4 rather. Measure of angle 1 plus measure of angle 4 is equal to 1/8. Does that make sense based on the picture? In the picture, which means they're supplementary, which means they're 1/8. They add to 1/8. Now, if we look at these two equations, the only thing that changes from one equation to the next is measure of angle 2 turns into measure of angle 4, and we get the same equation. You see that? Well, that's the same. Okay, we can turn around. So I'll do a little algebra on these to give you a little bit proof on it. On the first one, if we minus measure of angle 2, okay, from both sides, this one turns into measure of angle 1 equals 1/8 minus measure of angle 2. Okay? That makes sense? Logically? Algebraically? Can you guys see that? The bottom part, if we minus measure of angle 4 from both sides, we get measure of angle 1 is equal to 1/8 minus measure of angle 4. Does that make sense? So measure of angle 1 is this. Measure of angle 1 is also this. Using the substitution power, we can say that these two things are equal to each other because they're equal to the same thing. Okay? So we can actually say, we can conclude that 1/8 minus measure of angle 2 equals 1/8 minus measure of angle 4. That makes sense? If we subtract 1/8 from both sides, we get negative measure of angle 2 equals negative measure of angle 4. Divided by -1, we get measure of angle 2 equals measure of angle 4. And I know I ran out of space, which is kind of annoying. But just Well, what we said is what's actually accurate based on the algebraic properties that we've learned in the past. Measure of angle 2 is the same as measure of angle 4. Okay. Vertical angles are in fact congruent in all cases. Okay. So in this picture, the reason why it's 2 arcs on angle 2 and 2 arcs on angle 4, that represents that those two angles are congruent. Okay. 1 arc on 1 arc on 3, that means those two are congruent based on the labeling of the picture. All right, let's look at some representations of and identifying which are vertical angles. So we're just going to talk this through. We're going to talk 1 through 4 through together. We're going to answer what types of angles they are, just classify them, and then we're going to go some application of it. Okay, based on some of the things we do. So 1 and 2, measure of angle 1 and 2. Are those adjacent angles? 1 and 2 in the picture? Those are adjacent. Are they vertical angles? No, they're not across from each other. Are they? Do they? The complement is that they add one are added. No, because well, 2 is actually a 90-degree angle because this guy's 90, so this has to be 90. But anyways, they're only adjacent out of this stuff. And then 1 and 4. Let's take a look at 1 and 4. No, are they vertical? Yeah. Are they complementary? We can't really tell from the picture. So we just assume no at this point. Supplementary? Nope. They don't have one. Nope. Okay, 3 and 4. 3 and 4 are yeah, no. Not supplementary, not linear pair. If I have an angle like this, and then I have a second angle that comes off of it, I extend that ray. That means this and that angle are linear pair. They form a straight line, linear meaning line. Another version of it would be if I extend this angle and that one, those would be linear pair. Good question. So what? That was what would a linear pair be? Okay. So 1 and 5. 1 and 5. Those are adjacent. Are they supplementary? Are they a linear pair? Yep. Okay, let's do this. I want you and your role partners, I think we have had enough conversation as we've gone through class that I think you could read these problems, label the diagrams if you need to, and I think you could start to answer some of these questions on your own without my help directly. I'll come around and help you as needed. Okay? We'll work with your role partner, come to an agreement, and then I'll come around and help you out if I need to. I'm going to explain real fast how I get 5 and 6, and then we'll go on to 7. We'll actually do 7 2 ways. Okay? So let's do 5. 51 and y are vertical angles, so y is 51 degrees. 51 and x form a linear pair, so they add together to give us 180, which means x is 129. X and z form a linear pair, so x and z are vertical angles so that they're congruent, so z is then 129. X, so on 6 it says CBD and FDG are congruent. CBD, this is congruent to that one. Okay, if you didn't mark it and you had a question on how to do it, my response to you really should be, well, do it the way I do it. Which just means I would mark it in the picture, okay, to help me out. So I would recommend that you might also want to mark it. So then after you mark it, if they're congruent, they're equal. So you can just write 63 in there, okay? If y is 63, it's vertical to x, so x is also 63. All right, let's do 7. First way to do 7. Most people did it using a linear pair. Used these two and said that, oh, that forms a straight line right there. Okay, they are linear pairs, so we can add them up, and we can say that it is equal to 180, which is fantastic. Okay, and you get x is 8. Does anybody need any work in between? Okay, a second way to do it. Using vertical angles. What I mean by that is there's one set of vertical angles that are labeled. And on a test, it's likely that the problem will look like this. Look up how I changed it. I deleted that stuff, part of this stuff. Okay? It's likely that on your test, the problem will look specifically like this, which will force you to do it using vertical angles. Which means that these are vertical angles, so they're congruent. So, which means they're equal. That would be the setup for vertical angles. Does that make sense? Using vertical angles to solve it, you still get x is 8. Okay? After y'all get x is 8, to get LAT, that was actually there. So you would do 20 times 8 minus 5, and you get 155. To get TAO, you could do 180 minus that. You get 25. Or you could sub in 8 and get 25. In addition, to get PAO, that's vertical to LAT, so it's 155. Two ways to do it. Both are correct. However, you can't do it the first way if this is not there. Okay.